Hi, I'm Mike. I make music as Domestic Scene, and today I'm building the Elmyra synth by Neutral Labs. So over the last couple of months, I've been in touch with Manu from Exploding Shed, and as far as I know, they are the largest DIY synth parts and kits retailer in the EU. They're based in Germany. That's super convenient for me because I'm in Germany too. And yeah, so because of that, we've been able to get on the phone a couple of times and just chat. And it's been really cool to get to know a little bit more about those guys, about the passion that drives the company and kind of where it came from and where they're trying to go. So yeah, I really support those guys. I suggest you go check them out. But today I'm going to be building the Elmyra synth, which Manu offered to send to me. It's really exciting for me to build this because I've been really eyeing the Lyra 8, which if you've seen the Elmyra, you know that it shares a lot in common with the Lyra. I remember reading somewhere that Neutral Labs got in touch with Soma and asked for permission to build this synth based on the design of the Lyra. There's some key differences between the two. The Elmyra has 3 oscillators or 3 voices versus the Lyra's 8. There's some slight differences in the way that the signal chain works. But you've got the drone oscillators. In this case, it's a not quite sawtooth and not quite square wave oscillators that are running into a delay circuit and a distortion circuit. The Elmyra has a filter, which I don't believe the Lyra has, and I think between the two, maybe the biggest difference, other than the number of voices, is that the Elmyra is a digital analog hybrid synth, which, from my opinion, that's not a drawback. I love analog stuff, but I definitely believe that there's a place for digital in this space, and I think that a digital oscillator running through some analog circuits sounds great. So I'm excited to hear what it sounds like. The biggest difference between the two, the Lyra 8 DIY kit and the Elmyra synth, is how approachable the two projects are. So the Elmyra synth comes together with a faceplate and the case, whereas the Lyra, if you get it, I've looked through it because I was seriously considering buying it, and I probably still will. But you're looking at, I believe, 2 fairly large PCBs with jumper wires kind of going all over the place. It's a bit complex to put together, and once you deal with all of that, and once you source the parts, which in COVID times has been difficult, you're also looking at having to build a case and basically design and build a faceplate too. So that's just some extra hurdles to jump over to get to that final synth, whereas the Elmyra comes as a kit, got all the parts that you need, and you can build it. And I have an immediate need for some drone in a project that I'm working on, so I'm excited to get this done, plug it in, and see what it sounds like, and maybe make some music with it. So let's get started. I have everything laid out here, and the reason I pulled everything out of the bags is because I wanted to be able to show how many components were involved in this, and I think it makes a cool intro to do it like that. But it explicitly in the instructions says not to pull everything out of the bags, and the reason that it says not to do that is because the resistors are split into the different bags, and they're not labeled. So you can kind of deduce which value of resistor you have based on the contents of the bag. Let's see if I can grab. Yeah, so this bag, you can see it's labeled with what's in the bag, and you can look at the resistors that are in this bag and kind of course I grabbed the one without any resistors in it, but you can kind of just look at how many there are and then figure out what the value of those resistors is. So I didn't do that like an idiot, but I did label all of these. So I pulled them out, made the deduction, and then actually double checked with a multimeter the resistance value, and then just labeled all of these so I don't need to have them in the bags like that. And it's a lot easier if you just make sure that you keep it straight so you don't get confused when you get down to building. Okay, so the capacitor's long leg is positive. The negative terminal is marked with 2 little dashes. So if this thing blows up, then we'll know that it's the other way around. But I'm pretty sure the short leg goes in with the side with the negative, with the 2 dashes. Okay, so here's the itsy bitsy board, and you need to break the male headers and solder them directly to this board. And eventually we're going to have basically the mirror image with this header socket going down into the main board. So I'll start working on the itsy bitsy. So now I'm just doing one pin on each of these so that I can then make adjustments to make sure everything's aligned before I finish soldering everything up. And I'm just going to set that aside while I take a look at the sockets. And I think it's best because I can already tell that this is not aligned, so I'm gonna have to make some adjustments. Probably best if I do that while this is actually sitting in the socket to make sure everything will go together in the end. So with these female sockets also, I'm cutting them, basically sacrificing a pin each time I cut it. So I'm cutting right where the pin is because it's actually where the least plastic is. So hopefully you can see that I've just got my my snips right on a pin, and so when I cut it, that pin will just pop out. So there's a little pin kind of on my finger. That's what's inside one of these headers, and then I've just cut the plastic from either side of that pin, and that's how I make that cut. So yeah, now I'm just reheating that one pin that I put in as a quick tack bond, and just trying to straighten out these pins before I try to fit them into the sockets to hold. And if it's all looking more or less straight, then I'll try fitting things together. Alright, so then I've just got everything sitting together, but not pushed all the way in. So there's some gaps there, but it just makes sure everything's kind of more or less aligned. Okay, yeah, so I wasn't liking the look of the cut on this one here. it was making it a little tough to straighten out the two on the side, so I just cut a new one. This one's cleaner. So I think I'm ready to solder that up. So yeah, I would say this is probably definitely the most difficult part. It's just getting, that's 6 different moving pieces that you need to get aligned and onto this board. So just take your time with these headers. Make sure that the edges are trimmed up where you're doing your cuts, so that they're not pushing out other pins. And yeah, once you just take your time, only solder one thing at a time, check alignment, go back, redo stuff, move things around until you get it right. But then you get it right and everything starts to go together. So now I'm at that point, I'm just gonna solder it all up, and yeah. So yeah, I think that's it for this side of the board. Flip it over, put on pots and jacks and things. Well, I guess it's just pots and switches. I did notice when I was unpacking these parts that a lot of these pins on the potentiometers are a bit bent. It was like they were kind of a bit squished in the package, I think. But it's no big deal, just to bend them back into place. But unfortunately, I think I'm gonna have to do that to quite a few of them. Okay, so this is certainly going to be difficult to see on camera, but the wiring is like this. So you have the power input, and that's got a plus 5 volts, and that's this red cable, and that's gonna connect to pin 2. So you got pin 1, pin 2, so black's pin 1, red pin 2, white pin 3, yellow pin 4. So pin 1 is the audio out tip of the audio jack. So pin 1, audio out tip. Then you have your plus 5 volts coming in on pin 2. Your ground on the power jack runs out and grounds itself on the ring, and then comes across this ring and connects to this white cable, runs to pin 3, and then audio in is coming in on this yellow wire from the tip of the input jack. So those are going to connect to the board here next to this other cable assembly. So we've got pins 1 black, 2 red, 3 white, 4 yellow, and on the board here you got 1, 2, 3, 4, from the outer edge being 1. So in theory you just connect the thing that you can't see. Actually, I have another camera. What am I doing? We're going to try to connect black cable to the furthest out pin on that assembly. Hopefully you can see that. Get my hands out of the way. So, yeah, this isn't showing up very well, but doing the best I can. So, got black on pin 1, and let me just plug those in. And set that in there. So now we just test it. And if it works, then we can put all the rest of the fittings on, and we should be good to go. So this guy is USB powered, which is nice. So, if like me, you were hoping for the wonderful little blue LED to turn on, it did not, and that's because I forgot to solder it. So, I'm going to solder that guy and try it again. Hey, got power. No bad smells. I think that means we can put everything else on this faceplate and plug in some cables. Awesome. There it is. So let's plug it in and see what it sounds like.